The way that we determine the health of our streams is through multimedia sampling of the environment. We collect biological samples, so that means fish and macroinvertebrates. We collect water chemistry samples. That's actually taking a grab sample out of the water column and then analyzing it in the lab for different pollutants, measuring things like total suspended solids, biological oxygen demand, the amount of dissolved oxygen in the water, ammonia, things of that nature. We also look at the physical habitat in the stream, and we also do more detailed studies looking at pollutant loadings. So there's a integrated focus on collection of samples at a given point in time, looking at pollutants through administrative indicators such as the reports that we get from wastewater plants and other indicators such as land use that we could get from GIS. The different kinds and sources of pollution that we would find typically are permitted sources of pollution, oxygen demanding substances like carbon and ammonia. That just comes through the waste stream, is just a byproduct of life. And then another kind of pollution is more diffuse that comes from the landscape. Typically that's derived from agricultural sources or urban sources. Urban sources tends to be heavy metals and uncompletely burned hydrocarbons from gasoline or oil that kind of drips out of unmaintained cars, rubber that wears off, or the asphalt, that kind of stuff on the road surfaces and rooftops. And then from agricultural fields, it's really nutrients and sediment. When Ohio EPA finds that a stream is unhealthy, first we list the stream in our integrated biennial report. It's variously known as the 305B, 303D, but you would find it on our website as the integrated monitoring report. Once that stream is listed, we determine what pollutants are causing the impairment, and then we start a process to formulate a plan to reduce that pollutant to a level where we know it would bring the stream back into health. And that plan is called the total maximum daily load. So total maximum daily load is the load of pollutants on a given day that the stream can handle and assimilate safely without causing harm to the beneficial use that we have assigned to the stream. We use different kinds of biological organisms to help assess the health of the stream. The two indicators that Ohio EPA uses are fish and macroinvertebrates. So with the fish community in a stream, what we're looking at is the relative proportion of the different kinds of species that we find, the actual species, and then it's also what those species do. For instance, we'll get bass, like smallmouth bass and spotted bass. So those are species that are important, but they also represent top carnivores. And we assign a point value to how many top carnivores we're getting, and that factors into our rating of the health of the stream. Other kinds of fish that we look at that are in a stream of this size would be red horse suckers. Now, red horse suckers are very important because they feed on the macroinvertebrates that are produced by the stream. And so if you have a healthy macroinvertebrate population, you'll have lots of food for the red horse. And so we saw 4 or 5 different species of suckers, which is pretty good for what we'd expect for a stream of this size. Today we found a state endangered mountain mad tom. Mountain mad toms are important because unlike other fish, mad toms don't have scales. So they're very susceptible to industrial pollutants because they can just absorb the pollutants directly through their skin. The mad toms are what we consider a pollution-sensitive species. They're very sensitive to pollution. So if we don't find them in the stream, that might be an indication that we're getting, episodic events, pollution events that are causing them not to be there. Conversely, if we find them in the stream, we know that we're not seeing those types of episodic events in the frequency and magnitude which would preclude those fish from being in the stream. The kinds of species that tend to be more tolerant of pollution are species like carp. Carp were introduced from Europe back in the 1850s. They're naturalized into the system, so you would expect to find some. But it's only when you have really high levels of pollution that they tend to win out over the other kinds of species in the stream. Here we didn't happen to find any carp, so that's a good sign. What people can do to enhance and protect the streams in Clermont County, if you're a big landholder engaged in farming, the way that you practice your crop rotation is one thing. Whether you have filter strips next to the stream is something else that can be done. Whether or not you plow up the field in the fall or leave a residual cover on it through the winter so that you don't have erosion is something else. If you're a residential homeowner, you can be careful about how much fertilizer you apply to your lawn. If you have to blacktop your driveway, you can look for environmentally friendly blacktop formulas. If you're a municipality, there's certain things you can do to try to minimize the amount of stormwater that's coming into the system. Based on field impressions, we're seeing the kinds and types and numbers of species and the relative abundance that we would expect to find for the aquatic life use that it is. So it looks like it's in pretty good shape, and of course we need to go back and formally run the numbers before we can say for sure, but based on the field impression it looks pretty good.